Good morning, dear students. My name is Ferhan Mazher, and today is 11th of September 2021. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve May June 2004 Physics 5054 paper 1. This is an MCQ paper. It has 40 MCQs. I have already solved the first 20 MCQs, and we have uploaded that in my YouTube channel. You can watch that. That is by the name of May June 2004 Physics 5054 paper 1 part 1. This is the part B of that paper, and here we will solve from question number 21 to question number 40 of May June 2004 paper. So let's start today's paper, and we will be starting from the question number 21. A ray of light enters a glass block at an angle of incidence I, producing an angle of refraction R in the glass. Several different values of I and R are measured, and a graph is drawn of sine I against the sine R. Which graph is correct? Before you go into this question, if you can see the graphs here, on the y-axis we have taken sine I, and on the x-axis we have taken sine R. So the slope of these graphs will be sine I divided by sine R. Sine I divided by sine R gives you the refractive index of this glass. So you can understand that the slope of this graph is basically equals to the refractive index of the glass. Refractive index of the glass is approximately 1.4, 1.5, and its value is positive. So I will choose that graph out of these options whose slope or whose gradient is equals to is positive, and its value is round about 1.5. So we will do this actually, and I have done this on a paper. Let me show you my work and the question number 21. Let me show you. So here we go. Okay. So on your screen, question number 21 is showing up. You can see here that the B and the C options, they both are wrong. Why? The slope is negative. The graph is going downward as you move to the right. So their slopes are negative, so we will not consider them. So I am interested in the A part and the D part. Okay, in the A part, suppose I take this point on my graph, and let's check. This is the rise from this point to this point. This is rise, and this is approximately 0.7, 0.8, maybe 0.6. It's approximately 0.7, and this value here is the run, and that value is 0.5. So the slope is rise divided by run. So rise for the A is 0.7 and run is 0.5, so its value will be 1.4, so which is near to the actual value of the refractive index of the glass. So A can be the right answer. Now the D, suppose I take this point on the D, and this point on the D is 0 comma 0, and this point is 1 comma approximately 0.7 or 0.6. Okay, so the rise from this point to this point is this, which is 0.6, and this is the run, which is 1. And the slope is rise divided by run. So rise is 0.7, run is 1. So 0.7 divided by 1, that will give you 0.7. So the refractive index of this material is 0.7. So that cannot be our glass. Refractive index of this material is 1.4. That can be our glass. B and C, they both are rejected. The reason is their gradients, their slopes, they are negative, and the refractive index is not negative. So our choice will be A. I hope that you have understood that how we came to know that the option is A. So the option here is A, question number 21. I think that A is the option. Question number 21, A is the right option. So let's check if our answer is right. Question number 21A is the choice. A student starts to draw a ray diagram of an object at O near a thin convex lens, but is not sure whether the image is formed at X or at F. The correctly drawn image is, okay, so he is not sure whether this is the image or the image will be here. One thing I can tell you, let's take this to the paint. Let me open the paint first of all, so I can show you how this is done. Okay, so from here let me copy. Okay, so I will copy this diagram and I will take it to the paint so I can show you where the image is formed. Okay, so I bring it here. Let me choose a straight line. Okay, so let's choose red color. You see, this is the object, and one line is starting from the head of the object and passing through the optical center. It do not deviate, and when it do not deviate, it goes straight, undeviated. I will prolong this behind. Okay, so let me prolong it behind. So you can see here I have prolonged it. So now let me choose another color. Okay, so this another ray starts from the head of the object, goes parallel to the principal axis, and from here it bends and passes through the focal length, and it goes like this. So here these two lines, they are spreading out, kind of spreading out. So I don't think that they will intersect here because they are kind of diverging from each other. Don't get confused. This is a, I will prolong this behind the mirror. I will prolong this line behind the mirror. You can see these two lines have intersected here. So here you will have your image. Okay. So here I will have my image. So my image will be here. Here will be the image. Do you understand? So the image will be at the position X because this image is formed behind the, I mean, on the same side of the lens where you have the object. And so this image will be virtual image. And this image, as clearly you can see, its height is larger than the height of the object. So this image is magnified. This image will be virtual. This image will be magnified. And this image will be erect. It will be upright. So hopefully you have understood this. And let me show you. Let's check what's the answers. The image is virtual. The image is formed at X. So I think D is the right answer. So image will be virtual and it will be formed at X. Let's check. Question number 22. I think D is the answer. Question number 22. D is the answer, sir. Okay, so we are going to the next question. The next question showing up on your screen is, which diagram correctly shows the dispersion of white light by a glass prism? You see, when the light enters into the prism, when it enters from the first face of the prism, there the light splits. Okay, so A and D cannot be the answers. The reason is, when the light entered here at this face, at this point, the light has not split it. That's wrong. When the light enter at the first face of the prism, the light is supposed to split it into its colors. So A and D are straightforward wrong. So B and C can be the answers. Okay, so you know the order of the colors, we have a word for that, and that word is, what is that word? Remember this word. We say Roy G Biv. Roy G Biv. This is the word we use. And Roy G Biv. Roy G Biv means red, orange, yellow, green, blue, indigo, violet. Roy G Biv. Normally people read it Vibgyor, and but the right order will be red, orange, yellow, green, blue, indigo, violet. So out of B and C, the right order is given in the C option. So I think C is the right option. C is the right option. So you should remember this name. And let me bring it here. Bring it here. So Roy G. Biv, Roy G. Biv, red, orange, yellow, green, blue, indigo. So here the order is right. So C is the option. We think question number 23, C is the option. Yes, C is the option. So I hope that you have understood. Okay, so let's move to the next question. And okay, so let's go to the next question. Question number 24 on your screen. The diagram shows a loudspeaker that is producing a continuous sound wave of frequency 200 hertz in the air. So here you have the loudspeaker and it's producing uh, a sound of frequency 200 hertz. Which diagram best shows how the sound causes a molecule at P to move during 1 by 200th of a second? So you see, what does this mean? This means, you remember, if you remember, the 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 time period. The time period is the time period is equals to 1 divided by frequency. So it will be equals to 1 divided by 200 seconds. Okay, 1 divided by 200 seconds. So this is basically the time period. In one time period, this point will go forward, then come back, and then go backward, and then come back. Okay, so because here the sound wave is passing, it's a longitudinal wave. In the longitudinal waves, the particles of the medium, they vibrate parallel to the direction of the longitudinal wave. So this particle is supposed to move from right to left. Okay, so it will vibrate right to left. So I think A is the right choice. Okay, so let's check question number 24. A is the right choice. Okay, so the next question coming up on your screen, question number 25, and X of a metal rod attracts the N pole of a compass needle. What does this show about the rod? You see, if a rod, its one end, whose name is X, is attracted to the north pole of a compass needle, what does this show? It could be made of copper, but is not permanently magnetized. It cannot be, because the copper is not a magnetic material. Because the copper is not a magnetic material, so it cannot be attracted to the north pole of a magnet. It could be made of copper with the south pole latex. That is wrong. The copper cannot be a magnet. It could be made of steel but is not permanently magnetized. Normally, when something is made of steel, and we cannot say, because with the steel we normally make permanent magnets. It could be made of steel with the north pole at the X. Okay, so now we have to choose the best given options. It could be made of copper. That is wrong. It could be made of copper. That is totally wrong, because the copper cannot be attracted to the north pole, because the copper is not a magnetic material. A and B cannot be the answers. C, it could be made of steel but is not permanently magnetized. Permanently magnetized something is doubtful. It could be made of steel with the north pole at X. But if it has a north pole at X, then attracts the north pole of a compass needle. How come this be attracting the north pole of a compass needle? So because north pole and north pole, they are supposed to repel each other. So then the game comes to the point. C is not permanently magnetized. Maybe it's not permanently magnetized. I think C is the choice. Let's check. I'm not very sure. Question number C looks the best option. Question number 25. Question number 25. C is the best option. Okay. So you understand that how we rejected A, B, and D, and then we came to C, because C and D, they both are uh, D is totally wrong actually. So C is the right option. Question number 25, C is the best option. Okay, so we are moving to the next question. The next question coming up on your screen is question number 26. Four different substances are tested by using each as the core of an electromagnet. The number of paper clips each holds is recorded when there is a current in the electromagnet and when the current is switched off. You see, when whatever material you may use for the electromagnet, you should have as the core of the electromagnet, you have to remember one thing, and that thing is that the when you give it electricity, it should become a good magnet, but when you switch off the electricity, it should immediately demagnetize. So when the current is passing, it should pick up the paper clips, but when the current is switched off, all the paper clips should fall down. So that is very important. And for so let's check the option. He says number of paper clips held when there is a current in the electromagnet, and number of paper clips held when current is switched off. So when the current is switched off, all the paper clips should fall down. And when the current is given, and then the number of paper clips should be maximum. But the first point is very important, that when the current is switched off, all the paper clips should fall down. That is very, very important characteristic needed for any material to be used as a core in the electromagnet. When you switch off the current, all the paper clips should fall. So I think B should be the answer, because it is picking up six paper clips when the current is flowing through it, and it has zero paper clips when the current is off. The other computator can be D, but it's picking up less number of paper clips when the current is on. So B looks the best option. Let's check. Question number 26, B is the option. Yes, sir, that is the right option. Question number 26, B is the right option. Okay. So we are going to the next question. The next question is on your screen. You can see. Okay. So, and he says, on a stormy day, a large positively charged cloud is above a tree. An electrical charge is induced on the tree as charged particles flow through it. Okay. What is the charge induced on the tree, and how do the charged particles move? You see the top of the this tree, obviously that will become negative due to these the electrons from the earth and from the tree, they will come on the top of the tree with that, because here is positive, so the electrons are attracted to this. So the electrons will move from the ground and come on top due to this negative bottom of this due to this positive bottom of the cloud. The electrons are attracted, so electrons will accumulate here, so the top of the tree will become negative. So the charge on the tree, that should be negative, and negative charge move down the tree. No, the negative charge moves up the tree. Yes. So I think B is the best option. Question number 26, 27, B looks the best option, sir. 27, B is the right option. Okay. So here we go. Question number is coming up on your screen. Question number 28. The diagram shows two resistors connected in series with a cell. Which statement defines the potential difference across the XY? Across the XY, the potential difference is the amount of electric energy converted into any other form of energy when unit charge flows from X to Y. Or yeah. So the work done in other words, you can say the work done in driving a unit charge between X and Y. That's the definition of the potential difference across the XY. So I think D is the best option. It's not about the power. It's not about the power. It is about the work done in driving the unit charge through a component and when unit charge flows through that component, that is known as the potential difference across that component. So that was question number 28. We think that D is the right choice. Let's check. Let's check. Let's check what is the right answer. Question number 28. D is the right choice. Okay. So we are going to the next question, and that is question number 29. Which two resistors combinations have the same resistance between X and Y? Here we have different combinations of the resistors, and we are looking which two have the same equivalent resistance or combined resistance. So I will find out what is the combined or equivalent resistance of the P, what is the equivalent resistance of the Q, what is the equivalent resistance of the R, and what is the equivalent resistance of the S. And then we will decide that the same which two have the same resistance. Okay, so let me show you my work, and here we go. So it is coming up on your screen. This is question number 29. So and the first in the P, in the diagram P, the two resistors, they are connected in parallel to each other, so we can find out their equivalent resistance. 1 by R equivalent is equals to 1 by R1 plus 1 by R2, so it will be 1 by 2 plus 1 by 2, that will be 2 by 2, and 1 by R equivalent will be 1, so you cross multiply it, so you will have R equivalent equals to 1 ohm. In the same way, in the diagram, here we have the R diagram. The two resistors, they are in series with each other, so directly you can first two resistors, they are in series with each other. Let me show you the diagram. So here we go. These two, they are parallel to each other, so their equivalent resistance can be found. Let me show you. Let me show you. I think I made a mistake here. But let me check the first the S diagram for the S. The Q diagram here, these three are connected in parallel to each other. So you can find out their equivalent resistance. That will be 1 by 1 plus 1 by 1 plus 1 by 2. 1 by R equivalent will be like this. Let me find out that where I've shown here. Here is that. So here you can see that I have shown I think there is a mistake. This is the first one, which is exactly right, and this is the second one. So it will the RQ, the equivalent resistance of the circuit Q, that will be 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3, and one, you can see their LCM is 2, so 2 plus 2 plus 1, so it will be 5 by 2. Cross multiply 2 equals to 5. R equivalent will be 2 by 5, that will be 0.4 ohm. That will be 0.4 ohm. So that is the first circuit P. This is the second circuit Q. And then let's check what's the next. The next circuit is R. So you can find out these two, their resistance, that will be 1 by 1 plus 1 by 1, and then that will be 0.5 actually. And then I can show you here, because I think I made a mistake there in that. Let me show you here. So here we will have 1 by R equivalent, 1 by R equivalent, and that will be equals to 1 divided by 1 plus 1 divided by 1. So that will be something like 1 divided by R, 1 by R, and that will be equals to, so this is 1 plus 1, that will be 2, so you cross multiply it, so you will have uh, 2R equals to 1, and then the R will be equals to R will be equals to 1 divided by 2. Now, the combined resistance of these two will be 1 by 2, which means 0.5, which means 0.5. And then the combined resistance of the whole circuit, their combined resistance is 0.5. So with this, their combined resistance will be connected in series with this. So that will be 2 and plus and 0.5, and so the R will be equals to 2.5 ohm. So its resistance will be 2.5 ohm. On my slide, I think I made a mistake. So here this is a mistake. I think, yeah, this one is a mistake. Okay. So let me remove this from here. So, and let me bring this one here. I will bring this here. Okay. So let's paste it here. Okay. So the total resistance will be 2.5 ohm. I hope you can understand. And if you look at the next diagram is this one. So in this branch, the total resistance will be 2. In this branch, the total resistance will be 2. And because these two branches are parallel to each other, so I will apply the formula of the parallel resistance. So then you will be able to find out. So let me show you how we have done this. So the branch number 1 has a resistance of 2 ohm. The branch number 2 has a resistance of 2 ohm. Both these branches are parallel to each other, so their resistance will be 1 by 2 plus 1 by 2 equals to 1 by R equivalent. So that will be 2 by 2, and so the R equivalent will be 1 ohm. So which two will have the same resistance? This P and this one, S1. P and S that has the same resistance. So it went a little tricky. P and S has the same resistance, so that B choice. So B is the choice. I think highlight it. So B is the choice. P and S has the same resistance. So let me check. And that was question, I forgot it, 29. 29 B choice. Okay, question number 29 B is the right option. I made a mistake in the calculation when I did my homework. So please. Okay, so question number 30 is on your screen. In order to turn off both lamp, which is the safest switch position? Remember that the switch should be in the live, and where you can put here, you can put here, you can put here, you can put here. So where's the best location? I think A is the best location. If you put a switch here and you close that switch, both the lamps will be off. When you open, sorry, when you open that switch, both the lamps will be off, and when you close that switch, both lamps will work. So I think A is the best position for putting a switch, and 30 is A is the option. Okay, so that is question number 30. So the diagram shows a beam of electrons entering entering a magnetic field. So here one thing you should remember, he's talking about electrons. Electrons has negative charge. Okay, what is the effect of the magnetic field on the electrons? So I will take my right hand, my left hand, sorry, this is my left hand. So I will take my left hand and I'm going to apply the left hand rule on this. So so I will stretch my fingers like this. I will stretch my fingers. This is my left hand. I will stretch my fingers like this. This is F, this is M, this is C. FMC, F means the force, M means the magnetic field, C means the current. The current is going in this direction, and the magnetic field is going downward. and my thumb is pointing my thumb is pointing into the screen or into the paper. The magnetic field is going downward. The electric the charge particles, they are going to the right side, from left to the right side. My thumb is pointing into the screen, but there's a problem. The left hand rule is about not it's not about the negative charges, it is about the positive charges. So whatever the direction your left hand is telling you, the electrons will bend in the opposite direction. So when I applied the left hand rule, my thumb was pointing into the screen or into the page, so the electrons will bend opposite to that, because electrons are negative, and that left hand rule is not about the negative charges, it is about the positive charges. So what will happen, the electrons will be deflected out of the plane of the diagram, out of the screen. So they are deflected out of the plane of the diagram. So I think B is the right answer. Question number, sorry, I forgot. Question number 31, B is the right option. Question number 31, B is the right option, sir. A student pushes the north pole of a bar magnet into the end Q of a long solenoid and observes a deflection to the right on the sensitive ammeter. So there he is pushing the north pole of that bar magnet into the coil at the end Q, and there is a deflection on the ammeter towards the right. So there's a deflection in the ammeter towards the right. And what will produce a deflection in the same direction? So what will produce the uh, so pulling the north pole out of Q? No, that is wrong. Pulling the south pole out of and P, that's right. And pushing the north pole into and P, no. Pushing the south pole into and Q. So you see, uh, try to understand how do I know this, how I will apply this. Okay. So pulling the north pole out of, let me take this to the paint so I can show you easily. It's a little tricky one. Okay, so let me take to the paint so I can show you how this is done. So we are talking about this. He gave me a few options. The options are here. I will just show you how I do it. I'm just bringing that whole thing into here. Okay. Okay. With that. So if you will pulling the north pole out of Q. So if this north pole is pulled out, okay. So what will happen? When this north pole will be going to the right, on the Q, a south will appear. On the P, we will have a north. We will have a north, and here on the Q, we will have a south. Okay. So this is what will happen. Okay. Right now, what is happening in this situation? Look at here. What is happening here? When the north is coming in, okay, when the north is coming in, to stop this motion on the P, we will have a south, and here you will have a north. Try to understand what I'm saying. Okay. So here you will have a south. Okay. That is the rule, that when, for example, north is approaching Q, the EMF which is induced in the coil is in such a way that it tries to oppose this motion. So when the north is approaching on the Q, a north pole will appear to oppose this approaching north. So according to this, pulling the north pole out of the end q, so when you try to pull this out from here on the q to stop this motion, a south pole will appear, and obviously here the north pole will appear. Now let's check what will happen in this case. Okay, so here he says pulling the south pole out of the end p. So from here, if you pull the south pole out, to stop that, a north will appear here, and obviously the south will be here. Okay, and if you pushing the north pole into the end p from here, if you try to push a north pole into, so let's see what happens when you a north pole try to enter here. A north pole will appear, and on the q we will have a south pole. Okay, so again, so here he said pushing the south pole into the ends. If your south pole is trying to be entered at the end p, to oppose it, here south pole will appear, and on the q obviously the opposite, a north pole will appear. So where you have the same poles as these, as this, where is the same poles? In the D option. So I think D is the right option. I hope that you have understood this logic. D is the right option. Okay, so let me. D is the right option, sir. I think D is the right option. What will produce a deflection in the same direction? We think D, because D is the only motion when you will have the same pose on the coil, which are produced right now. Okay. So question number 32, D is the option. Question number 32, D is the right option. It was very tricky. Hopefully you have understood. Okay, so we are going on to the next question. The next question is a bit tricky. Okay. A simple AC generator produces an alternating EMF as shown. So the voltage is 1 volt and the time period is 2 seconds. The time period is not sorry, not 2 seconds. The time period is 1 second, because in 1 second a wave is completed. The speed of the generator is doubled. When you double the speed, what will happen? The EMF produced will also become double. So it will be no more 1 volt, it will become 2 volt. When you double the speed of the generator, the the voltage produced, that will also become double, and the time period will become half. If the wave was completed in 1 minute, now the wave should be completed in half the minute. In 1 minute, if there were, for example, two, sorry, I'm saying minutes, seconds. In 2 seconds, there were two waves. In 1 second, there was one wave. Now when you double the speed, in the 2 seconds there will be four waves, and the time period will become and the voltage will become two. So here we have one wave, two wave, three wave, four wave, and the voltage has become double. So when you double the speed of your generator, what happens? Actually, the voltage becomes double and the time period becomes half. If on the display there were two waves in 2 seconds, now there will be four waves in 2 seconds. So I think D is the right option, sir. D is the right option. Question number 33, D looks the right option. Let's check. Question number 33, D is the right option. So let's move to the next question. The question number is 34. Okay. A step down transformer changes 240 volt AC to 12 volt AC. There are 600 turns on the primary coil. How many turns are on the secondary coil? So the input voltage to the transformer is 240. We call it the primary voltage. And the output voltage is 12 volt. We call it the secondary voltage. So there are 600 turns on the primary coil. How many turns in the secondary coil? Very simple. Let me show you my work. And here we go. So here we go. So question number 34, the primary voltage is 240 volt, the secondary voltage is 12 volt. The turns in the primary, there are 600, and the number of turns in the secondary, that's question. And we know that NS by NP is equal to VS by VP. NS is the question, NP is 600 equals to the VS is 12 volt and the VP is 240. So just cross multiply it. Ns will be equals to 12 into 600 divided by 240, and Ns will be 30 turns. So the number of turns in the secondary is a step down transformer. There will be 30. So there will be 30 turns in the secondary. So let's check what's the option. There will be 30 turns in the secondary. So we think 34B is the right option. Question number 34B is the right option, sir. So let's move to the next question. Okay. Why are high voltages and low currents used to transmit electric energy over long distances? You know the power loss in the transmission line is given by P equals to I square R. P equals to I square R. So the power loss, because the resistance, to change the resistance of those transmission lines is very difficult. So what we do, we reduce the amount of current. Power loss is equals to I square R. So if you are able to reduce the amount of current flowing through them, the power loss will reduce. So that is achieved by using step up transformers. We increase the voltage, and when the step up transformer increases the voltage, the current reduces. So so that helps in reducing the power losses in the transmission lines. So why we do this? To reduce the heat loss from the power line. So I think C is the right option. Question number 35, C is the option. Question number 35, C is the right option, sir. Question number 36 is showing up on your screen. A variable potential divider has a sliding contact S that can be moved between and P and Q. It is connected to a constant 6-volt power supply as shown below. What happens to the potential difference between X and Y as S moves down from P to Q? You see, this is a sliding potential divider. So wherever you put this contact, the upper portion will be act as R1, and the lower portion will act as R2. R1, R2. So if you have taken V out from the R2, if you remember the formula of the V out, I can show you here. The formula, if you have studied that book, the formula for the V out, the formula for the V out V out is equals to, the formula is R2, R2, and R2 means the subscript is R2. So R2 divided by the total resistance, and that will be R1. So that is R1 plus R2, bracket close, and the whole thing multiplied with, not here, multiplied with V, voltage of the battery. V multiplied with the battery. Okay. So that's the formula of the potential V out from the R2. When you move this sliding contact, the V out here depends upon this R2 value. So if you move it towards the Q, this R2 value will decrease. When the R2 value will decrease, the V out value will decrease. So when the contact is at the P, so there is no R1, so the V out will be equal to the voltage of the battery. So as you go down, the R1 value increases, the R2 value decreases. So this V out value will decrease, and when you reach the Q, the V out value will become zero because the R2 value has become zero. As you go down, the R2 value decreases, R1 value increases. So as the R2 value decreases, the V out decreases. And when you reach the Q, the R2 value becomes zero. That's why the V out will also become zero. So the value of the V out will vary from 6 to, I think, from 6 to 0. As you move down, when it is here, the V out here will be 6 volt equals to the voltage of the battery. As you go down, this V out will gradually decrease. When you reach the Q, the V out value will be 0. So it decreases from 6 volt to 0 volt. You should read your concept of your potential divider. I have tried to show you how this is done. Hopefully you understand this formula. You recognize this formula. So that's A, question number 36. Let's check what's the option. Question number 36, A is the right option. So let's move. Okay. So on your screen, we have question number 37. A capacitor C charges when it is connected to a DC power supply. So here we have a DC power supply. Which arrow shows the direction of the conventional current when the capacitor is charging? The conventional current comes out of the positive and it goes like this. So I think one is right direction and question three is right direction, because the conventional current flows from the positive and it goes to the negative. So one and three looks the right option. One and three is the A option. Question number 37, A is the right option. Yes, sir. Question number 37, A is the right option. Okay, so we are going to the next question. That's question number 38, showing up on your screen. Two types of emissions from a radioactive source are separated by passing them through a magnified field. The deflections are shown in the diagram, so you can see radiation is coming, then it has passed through the magnetic field, which is into the page, and the radiation has split it into two. So one radiation has gone undeflected, and other radiation has bended towards the bottom of the page or towards the bottom of the screen. So the question is, what are the emissions P and Q? The P is no doubt is gamma rays because it has been undeflected. The P is gamma rays because gamma rays don't have charge on them, so they are not affected by the magnetic field. They go undeflected, so there is no effect on them. So I think C and D is the option. Q bended towards the bottom of the page. So now we have to apply the left hand rule. So let's apply the left hand rule. The magnetic field, as you take your left hand, this is the second question which is using the left hand rule. So be careful. So this is my left hand. This is my left hand. So I will stretch the three fingers of my left hand to apply the left hand rule. So the magnetic field is into the page, into the screen. So this finger, which represents the magnetic field, is into the page. The charged particles are going towards the from right, from left to right. Okay. So my thumb is pointing towards the top of the page, but the particles have not bended towards the top of the page. They bended opposite. So so they are not obeying this left hand rule. They are bending opposite to this. It means they are negatively charged because this law is for the positive charges. So if the Q has been positive, it should have followed my left hand rule. It has gone opposite. It has gone towards the bottom of the page instead of going towards the top of the page. So it means that the Q is negatively charged. If the Q is negatively charged, then definitely it's beta particles, because the beta particles are like electrons. They have negative charge on them. So the question number 38, I think D is the right option. Question number 38, D looks the right option, sir. Question number 38, D is the right option. So let's check. Question number 38, D is the right option. Okay. So we are moving to the next question. A narrow beam of alpha particles is fired at a thin piece of gold foil, which is the final direction of the largest number of alpha particles. So this is the Marson experiment, Geiger and Marson experiment. They took a gold foil, a very thin gold foil, and they bombarded alpha particles on it. And with the help of a photographic film, they observed that what happens with the alpha particles, in which direction they go. So the most of the alpha particles went straight, like there's nothing in their path. Very few alpha particles were deflected on a larger angle, and very few particles were deflected backward. So most of the alpha particles went straight, undeflected, like nothing came in their path. So A is the option, I think, sir. Question number 39, A is the right option. Okay, so we are going to the next question. That next question is a little tricky one. Here we have question number 40 coming up on your screen. He says radon decays with a half-life of 1600 seconds. And Rn, I'm not sure about the name, decays with a half-life of 52 seconds. PO, polonium, I think. I'm not sure about the name. decays with a half-life of 9.1 second. And this symbol is for lead, decays with a half-life of 10.6 hours. Okay, so the changing count rate of for one of these radioactive nuclide is shown in the graph from the half-life shown by the graph, which has the decaying radioactive nuclide. I don't know what's the background radiation, so I'm not considering the background radiation. So simply directly we are going to find out. Okay, and the half-life. So what's the count rate here? It's approximately 65, 64. The reading is 65. When the time is zero, the reading is I think 65. So so 64. Okay, okay, 64. So divided with 2. So you get 32. So where is the count rate 32? Here we have the count rate 32. And what is the time below it? When the count rate is 32 here and here, so it's 50 something. So in 50, this became half from 64 to 32 in how many seconds? 52 seconds, 50 seconds approximately. So which one is the right answer? Which one is the right answer? 50, 50, 50. This one. Okay, it has the half life of 50 something seconds. The rest are not near it. So I think the RN B looks the best option, sir. B looks the right option. Let me reduce the size so you can see the whole question. I think that the B is the right option, and I hope you understand how we have done. Question number 40B is the right option. So, my dear students, today we are done with this question, this paper. So, in this video, that was the B part of this paper. B part means we did it in two videos. In the first video we did 20 questions, and in this video we that's the part B. We have done question number 20, 21 till question number 40. So that was May June 2004 paper, and we have completed this paper. Hopefully this video is helpful to you, and I hope that this is very useful to you. If you have a hard copy of this paper and you pay attention and you try to understand the concepts, I hope that this will be very helpful to you. This video will be very helpful to you. I also want to make a request that if in the whole world, wherever you are, if you find my video very helpful to you, do me a favor, share the link of this video in your Instagram or in your Facebook. That will be a very very helpful thing for me to promote my channel. So thank you very much everybody, and have a good day, and God bless you all.